Good morning, everybody. Welcome to the stream. Today, we're going to be discussing a few more points about UCSs in general, and we are actually going to go through several different iterations of a UCS that was submitted to us by somebody on the Cabinet Vision forums, Jeremy Cook. So thank you, Jeremy, very much, if you happen to be here. So what Jeremy's UCS does, basically, and I've gone through and I've really I've done a lot to it since he passed it off to me, and there's a lot of reasons why, most of all being that it's very difficult for me to talk about somebody else's code versus if I write it myself, it's my own creation. I know it intimately. So it's not going to look exactly like what his did, but the function is pretty much the same. So basically, this UCS adds a coat hook to cabinet ends or cabinet partitions, whatever parts you list, really. But as it came to me from him, it was for finished ends, unfinished ends, partitions, maybe dividers. And so before we jump into that, I want to talk about models for just a moment. And material models, I'm not going to cover too much here because there's a lot to them, and maybe we should do a video on material models, but basically, you can model things with SketchUp or import models from other people, and you can assign operations to them. The models are a little bit limited, but it's not that bad. They're pretty good. So let me see if I can find my hooks. Here's Jeremy's coat hooks, but all right, so these are the various hooks that I've imported from the tag hardware collection. You may not be able to get this if you don't have the closet package, but you could just ask me and I'll give it to you. I don't really care. So if you do want these and you can't find them on the forum somehow, send me a message and I'll try to send them to you. But basically, you've got these different materials is what they amount to, and when you go to edit the material properties, you can click on model, which takes you to this new window here. And so here's this tie hook rack from the tag closet accessories collection, and I have several different hooks like this, and along with these hooks you have some mounting holes. And this is really why I'm in here talking about this at all. When you write a UCS to add a piece of hardware to something, a lot of times it's enough work in and of itself just to get the hardware in the right place. And that's a whole set of basically, dim some kind of part as a new part type and size it and place it where you want it. So that's a whole set of code that's going to create an object, rotate it into place, and place it where it needs to be. So if you have to do that as well with 3 separate mounting holes, for example, or in this case 2, I would do this as a 1 line bore with a spacing and a repeat value of 2. But the point really is that you would have to do several iterations of code, repeating it over and over and over, and really increasing the length of your code in general to get these operations to be placed correctly along with the hardware object that you're trying to add. So something that was really, really cool about when Cabinet Vision introduced models was the ease with which you could add operations to a hardware model. And this dramatically simplifies code writing for us, because now you can kind of treat this as like a package deal, if you will. And rather than having to have several iterations of code to place not only your hardware but your operations correctly, now you can use the hardware object itself as a reference and place the operations where they would go on the hardware, which is really easy to do because, generally speaking, if you're going to be using this, you probably have access to some of the hardware. You can take measurements if you can't find measurements online. And basically, you know, in relation to the actual hardware piece, you can place your operations. And then in your UCS, that reduces your burden significantly, because now all you have to do is just write one iteration of that placement code to get your hardware where it needs to be. And then because that hardware model's carrying the operations with it already, now, you know, 900 lines of code turns to 300 lines of code, or 90 to 30, or whatever. You know, it's just dramatically less. So I preach very much the use of models with your materials whenever you can. And just a sort of aside, I really like models versus library parts. Before models were a thing, the only way we could really even do this was with library parts. And one of the really cool benefits of the model versus the library parts is that you don't get any of these snap points that we're seeing here in the model space when you're actually rendering them in Cabinet Vision. And that can be good, that can be bad, but for the most part, it ends up being a really nice performance improvement, because I find that rendering snap points is what slows my software down really more than anything. So somebody in chat is here saying, right, no CAD overlay is a pain, and it is. It is, but I don't know. You do what you can, right? But so anyway, this really, I wanted to just talk about this primarily because this is the way that I'm going to be writing my UCS. I'm going to be dimming a piece of hardware, and I'm going to be assigning material IDs to the hardware. And if you've been using Cabinet Vision for a while and you understand best practices, you're probably saying, you're going to do what? But what I have actually found over the past few versions, and I think this has been confirmed by some of the people higher up at Cabinet Vision, it's that they have done a lot of work to actually significantly reduce the impact of assigning material IDs through UCS. And truthfully, I use it all the time now. That was a really nice thing for me to hear, and I was uncertain about it at first. And I was always testing to see, is there a difference if I'm doing this or not? I really feel like they've actually gotten it to a point to where there's almost no negative impact when you're assigning material IDs, or at least for the way that I use the software, I'm not seeing an impact. And so you can use that to actually swap your models out, because each material ID can have an individual model associated with it, and you just get a lot of flexibility. And I'll show you later in the UCS. So anyway, enough of that. All right, I'm just gonna delete everything out of the cabinet so that it's as clear and clean as possible for us to see. So I have, at this point, I've gone through and I've created several iterations of this UCS that we're gonna go through. And I did this because the final version, it's not really overly complicated, but I want this to be accessible by everybody. And so I thought that it would be best if we started with a really, really, really simple UCS to build upon. So this first one here, 36 lines. This is really, really short and sweet and simple. So let's just start by taking a look at this line here, because this in and of itself can be kind of daunting because there's so much going on here. So to simplify for this particular stream, I'm actually going to condense this so that we're only going to be working with for each LU part. So that's going to be for each left unfinished end part. So we're going to keep this UCS so that it is only going to work on left unfinished ends. So the first thing that you're going to want to do usually with the UCS is you need a way to turn it on. Unless for some reason you want your UCS to work for every single situation that you're in, you need a way to turn it on or off. And so in this case, if we didn't have an on or off switch, every single left unfinished end part that you have in a job would get this hook, which is obviously not what we want. We want to only put a hook on the left unfinished ends that we select and say, you know, hey, I want a hook here. You know, the customer's requested it, or I think it's a good design idea, or whatever it is, right? So we do that by defining an attribute or a parameter or a note. I think it's best to use an attribute for this type of thing so that when you're working in the software, you click on the part and you can see it immediately in the sidebar on the left. And so the difference, if you don't really know what the difference is between a standard parameter, an attribute, or a note, standard parameters can only be viewed through the parameter tree. Notes can be viewed through the notes section in the properties window of the part or assembly. And attributes can be viewed on the bar on the left-hand side of your screen. And we'll talk a little bit more about that. But that's basically, simply put, that's how those three different types of parameters work. Okay, so how do we set this up? So basically, when you're writing UCS, once you've defined your for each line, which controls which part you're actually going to be doing the work on, there are certain rules that apply. You can't just type what you want to type and have it, you know, do what you want it to do. Well, you can, right? But you have to use the right language. So the way that we do this is, sorry, I just want to keep this kind of simple and not overwhelming and not distracting. So these 5 lines of code here are basically first checking to see if the parameter we're trying to create exists. And if that check succeeds, in other words, if the parameter we are deciding to define does not exist, then it will make it to the next set of lines, right? So think of this part here of line 8. This is kind of like a logic gate. And if the equation or the expression, if you will, within if and then is successful, then you get to make your way down to the next line, I guess, is the best way I can sort of describe this. So what we're going to do is we want to define an attribute, and we want to first check to see if it's null or not. And again, null just means it does not exist. So why are we doing this check rather than just defining it? Because we know, you know, this is a custom attribute, so of course it doesn't exist. Why are we checking to see if it exists? Why not just say, here it is, and this is how you use it, and this is what it says, you know? Why not just have it basically read like this? And sometimes you can. But you don't want to write your code that way if you want to have the ability to change the value of the attribute that you are creating. So in order to be able to change the value, you have to create a condition where you only define the value one single time, which is when the attribute is null. So again, if it doesn't exist, then we're going to create it with this value. And that's the end of the logic gate. So as you think about it, the way code in a UCS is processed, every time Cabinet Vision goes through a rebuild process, every time you change a value on a cabinet or change properties in a room, the user created standards list is processed once again. So it basically just rereads the code every single time. So the first time our left unfinished end part reads this code, it's basically going to say, do I have the attribute JDC underscore add coat hooks? If I don't have it, then I want it, and I want the value to be 0. And then, we'll decide how to display it and what the description is and whatever. So then the next time this left unfinished end gets processed by the code, when it checks to see if the value is null, now it's going to fail. So it's not going to change what that value is. And that's the only way that you can set these things up, so that you get to define it with a default value and then get to later modify that value. So that's what this whole, from line 8 to 10, that's what this whole thing is about. It's checking to see if it exists, defining it when it does not exist, and then leaving it alone otherwise, which means that now the user has total control over it. So this next part here, line 11, is really just what's defining how we're going to look at this parameter, how we're going to be able to access it. So with a style of 1, I'm defining that it's going to be an attribute. So David is saying, as you guys can see, right, this is also the only truly consistent use for the null keyword. And he's right. There's really no other reason to use null other than to check for whether or not something exists. You won't really see it anywhere else in your code writing for the most part, because there's no point. Yeah, so really you're only going to use null when you're defining an attribute or a note or a parameter that you would like to be able to control later. So then again, so the style now, with a style of 1, we are saying that when I click on my left unfinished end, I want to be able to see my attribute in the left-hand corner or the left-hand side of my screen, what I typically refer to as the sidebar. And then my description here, again, I have to type the name of the attribute and then description, so that I'm defining the description of the attribute that we defined up here. I'm setting it so that it's going to read hooks 01 add hook. Now I got a little bit ahead of myself here, so I'm going to go back to this for just a second. What does BOOL mean here, right? When I'm defining a parameter of any sort, I need to define the type of parameter. And there are quite a few different types of parameters, and they have different purposes. So a measurement parameter will correctly hold any sort of dimensional number regardless of the unit precision. So 1 inch is 25.4 millimeters roughly. So when you define something as a measurement and you say you want it to be 6 inches, if you give your UCS to somebody that works with metric precision, that's still going to work. Your values are still going to translate correctly, and everything will work with what you're trying to do. So that would be like what a measurement parameter would be. So this one here, BOOL, this is a Boolean parameter, and basically a Boolean parameters are either true or false. So a 0 is going to be the same thing as false. a 1 is going to be the same thing as true. I don't think you can define Boolean values as anything other than 0 or 1, and you shouldn't try, because then you're just going to confuse everybody else that's trying to look at your code and help you. So, you know, whether or not it's possible, I would suggest you don't do it if you want people to be able to help you. So then some of the other different styles that you may have seen me use or talk about in the past are integers. And integers are just going to be your whole numbers, you know, 1, 2, 3, 4, 5, etc. You can also define things as currency. And you can also define things as decimals. And then I'm fairly certain there's also a degree definition. But for this one in particular, we've defined it as a Boolean parameter, because we want this to be a true or false statement. You know, do you want to add hooks to this panel? True or false? If it's true, you're going to get hooks. If it's false, you're not, because that kind of makes logical sense. I also like using true false versus a drop down list for yes or no, because it's one less click, basically. And that's just how I am. I don't know. Maybe it's a little bit neurotic, but if I can save clicks, I'm going to wherever I can. So I try to use true false if I really only is a switch, and I try to only use list drop downs when I need more than 2 choices. So again, right, what we've done here is we've defined the name of the parameter that we want to utilize to sort of trigger this UCS to be on or off. We've checked to see if it exists or not. When it does not exist, we've defined it as a false Boolean statement that we'll be able to see on our sidebar as an attribute with the description that says hooks, you know, add hook. So at this point, if we had nothing else in this UCS, right, which we can actually ignore all of that because we've got an exit statement next that will have all of the left unfinished ends bail out of this UCS if this attribute has not been changed to 1. And if it starts by default as 0, then it could never have been 1 yet, and therefore we know that nothing else has occurred. So let's see what this actually does. Now I've got a bunch of other attributes here that I didn't take the time to remove, and I apologize, but what we're trying to focus on is this one here that we have added, right? If you recall from the screen before, this is the description that we've defined. So because we've set the style as 1, it appears here under the attributes. And then when we checked to see whether there was a hook or not, and whether there was a parameter for this or not, there was not, so we defined it by default as false. I'm going to show you a way that you can kind of like reset these things. Basically, if you go to the parameters tree and you find this one, if you come over here, well, you don't really need to go anywhere with it, but the description and UCS is helpful for determining, you know, what these come from if you're looking for that. But for what I'm trying to show you, basically, if you select this and you delete it, now when I click OK, the UCS is going to process again. And when it processes it again, that question, that query at the very beginning that checks to see whether it's null or not is going to be true again. So it's going to define it once more. So as soon as I click OK, you would think that perhaps we won't see this over here. But we will, because it came right back. Which is one of the really good things about defining this type of attribute with the UCS. Your end users can't accidentally delete it and lose it forever, and then everyone's confused about why things aren't working right, and how long ago did that happen, who knows, and all of that mess. So this is one of the main reasons that I really like to define attributes with UCSs rather than through the system parameters menu. So now that we know, and I'm going to just kind of I'm going to force an exit statement after this and show you guys one more thing about this. So when we say true or false, this is literally how it's going to work over and over. This is all this attribute is ever going to do. But when it says true, normally we want the rest of the stuff that's going to happen with the UCS to occur. Let me set it back to false before we do this. So when you're writing your UCS, I think I've talked about this a little already, but you want to exit as quickly as you can once the most parts that will be affected by our UCS have done what they need to do, basically. So this command here, exit, basically says stop everything you're doing right now, don't read anything further beyond this line, and just get out and move on with life. It's the fastest way for you to basically stop a UCS from running. And you might wonder like why this matters. Why use an exit statement rather than if condition, then do things, and if sort of filter. And the reason for it is your parts that don't pass your if-then filters still process all of those lines of code all the way down to the bottom of the UCS before leaving it, if they don't have a command that tells them to exit right now. And it might not seem like much, and for the most part it's not for a really short UCS like this, but as you guys can see, like I have a stupid number of UCSs, and a lot of them are turned off because they're just me testing things or doing this streaming stuff. But when you end up with a lot of code, it can end up slowing you down. So using your exit statements wisely is really, I very strongly suggest doing it. And so that's what this next part is. I want every single left unfinished end part to get the option to receive hooks on them. But when we haven't decided that we want a left unfinished end part to get a hook, we want them to stop processing the remaining, 20 lines of code, because they don't need to. There's no reason for it. So basically, once we've defined the parameter or attribute that will be our logic gate to make this happen, then I try to immediately afterwards put an exit statement. If you're not trying to do what if I'm not telling you to do what I'm writing past this point, don't waste all of our time, is kind of how I think about it. So, all right. This next little bit is basically where I've defined some placement, or where Jeremy really defined some placement values for the hook. So I've talked about this a little bit before, but when you are defining parameters, I find that it's extraordinarily valuable to put, like your initials or your company initials or some sort of unique identifier before you name your parameter. So in this case, Jeremy is the one who gave us this UCS. And so as I was going through this, I renamed some of his parameters to have JDC in front of them for his initials, because that does two things. One, it lets you know that it's a custom parameter that you're going to do something with, and two, it kind of also gives you a little bit of a breadcrumb trail to who wrote it, and it kind of gives credit to who did it, in a way. So I think it's very valuable to always put a prefix of some sort on your parameters that you're creating to help you know when you're working with a system parameter or not. So JDC underscore hook X, right? This is what's going to control the X placement of the hook that we want to add. And so that's why I have kind of written it out this way. And you can use way fewer characters if you want. If you wanted, you could just make this say like JDC HK X, right? And when you're writing this that HK is short for hook, And so that's why you want to write it that way. But guess what? I don't know what that is. I guess what, like, any of us don't know. You know, we don't know what this means. So again, if you want to write your code in a friendly way where other people can look at it and help you, I personally find it to be valuable to just write out your parameter names as much as you can. Don't get too wordy, but for the most part, make it very descriptive, because I know exactly what this is when I look at it. This is obviously the hook's X position, and you know, I can sometimes infer from what the description is, what the author of the UCS was going for here, but it's best if it's just really clear. So we're going to define, when we decide, let me see. While we're defining our X and Y values, we're first going to check to see if they're null, so we can establish a default value that makes sense for the most time, like for the most part. Sorry, I had a value there that I didn't need there. So basically, I want this to be right in the center of the left unfinished ends part. So I'm going to define it as dx, which is a value that references the part's width, and I'm going to divide that by 2. And David brings up a very good point, and that has happened to me on a couple of occasions, and it's very frustrating. Sometimes you have a very, very long filter line for whatever reason, or really long line of code referencing a bunch of parameters. If your parameter names are too long, you're going to run into a maximum character limit for your line, and you're going to have to do some acrobatics to make it work. Sometimes it's very frustrating, and there are some other ways to get around that. You know, you can do some calculations prior to your equation lines to reduce the character count, but sometimes it's just, there's not much else you can do, and you do need to go back and abbreviate. That's a very, very good point. So anyhow, if you followed along closely with this, I'm not going to, you know, we spent 30 minutes already at this point kind of talking about this. I don't want to go again over these things in the same amount of detail, but I just want to point out a couple of things. It's the same style. So we know with the style of 1 for our X and Y values for our placement for this hook, we're going to have them as attributes. They're not going to be created until we make it past this exit check. So basically, until you select a left unfinished end and you tell it you want to have hooks so that it can make it past our exit on line 15, it will never have these parameters defined for it, which is really good for reducing your clutter, for keeping your workspace kind of tidy. That space on the left-hand side of your model space is surprisingly much smaller than it feels like when you really start developing your software. So anyhow, this is our face X position and our face Y position. So we're checking to see if these values exist. If they do not, we want to put them right in the middle of the part, right in the middle of the left unfinished ends part. So dy divided by 2 is the length divided by 2, and dx divided by 2 is the width divided by 2. And by the way, I want to make this really, really clear. If anybody in the chat has any questions, fire away. Like, please. This is going to be a pretty long stream, and I don't mind pausing for just a minute to try to explain something if I'm going too fast or if I'm not doing a very good job of kind of fully getting the point across. So feel free to ask me to just pause for a minute and talk more about something if you're not understanding it. So, all right. Once we've defined the X and the Y placement of this thing, which are the only 2 values that we care about controlling, because we want to move it, you know, as we're looking at a cabinet and we attach this hook to the left end, we want to be able to move it up or down or in or out. So we've got X and Y parameters that we're going to assign to it. We don't need to move it away from the panel, so there's no reason for us to try controlling the Z variable. We just want up or down and in and out right now. So once we've established all of the necessary controls, we want to be able to turn it on and we want to be able to move it around. Now we have to actually do the part of the UCS that adds our model or our hardware or whatever it is. So I am dimming hardware as new hardware, and basically this is kind of a I'm not going to talk too terribly much about this, but the item that you dim here, whether it's a pull or a hardware or a part or an operation, is important. This, however, is not, gosh, this one is just as important as well. I think I mix this up a lot, but basically, you want the first part of your dim statement to, let me see. I really don't want to give bad advice here. So we're going to reference the help file. By the way, I think we did go over this a little bit in the last video, but under the functions and operators topic, you can see exactly what the different types you can define are and their styles. So okay, so that's right. I think hardware as new hardware is the thing that always confuses me because it sounds I don't know, it just, to me it sounds stupid. I will definitely let you know. So John Atkin says, basically, right, they find the parameters that pop up. If you answer yes to the first question, don't go away when they turn it off. There's a couple of different ways that we can address that, and we will definitely talk about that a little bit later. I've got an exact example of that. So the reason dim hardware is new hardware always kind of like confuses me is because hardware is not only a part type, but it's also like a part, right? It's also a part name. So it's a part name and a part type. So you can dim like board or AS or, you know, FS or LU. These are just the internal part names. Hardware is also an internal part name. But if you're dimming it as a new hardware type, I believe it's got, it basically just behaves a little bit differently than if you were to dim it as a new part. And I don't think you can pull the model in if you dim it as a new part the way you can as a new hardware. So basically, when you're trying to add an accessory of some sort, a piece of hardware where you want the model to show up, you should be dimming it as a new hardware. It doesn't have to be dimmed, it doesn't have to be hardware as new hardware. You could make your own part for it. You could make belt hook if you wanted, or coat hook, or whatever as a part, and this would still work just as well. But for me, in my mind, these all kind of fall into the same category as hardware, and that works only because I'm defining the material ID for my hardwares. So I worry that what I just said may have confused some of you who aren't super familiar with this, but basically, in every other situation, I advocate for building specific parts, very much for building specific parts, because if you build specific parts, then you can assign specific materials to them in their material schedule. And at that point, you don't need to assign a material ID. That part will always be the material that you've assigned it to in the material schedule. So I strongly advocate for that in almost all cases. Hardware and accessories are the one place where I don't follow that rule personally. And you don't really have to do it the way I'm doing it. This is just a way. And I find that for me, this makes my my hardware UCS is extraordinarily flexible, because now I'm not locked into individual part names that I have to go through and change if I want to write a UCS to add belt hooks, and then one for coat hooks, and then one for tie racks, and then one for valet rods, and then one for belt racks, and et cetera, et cetera. So I like to use hardware for my hardware objects. So yes, Jeremy says the basic structure is dim part name as new object type, and that explains it perfectly. Thank you, Jeremy. Perfect. All right, so basically I'm saying dim basically means like add or create. So I'm going to create my part name, hardware, as my object type, new hardware, right? So at this point, the structure, the syntax for defining the different characteristics about the object that we're creating is part name, period, part parameter. So hardware is our name. Period basically just means now we're going to define a value or a parameter that is associated with the new object or part that we're creating. So the hardware's name is what this line says is going to be coat hook. And you have to put strings of information like text, like if you want to name something specifically without actually defining a value, you have to put that within quotes like this. So if I didn't have quotes like this, not only would I get I'd get a syntax error because I've got a space here, and you can't have space in your you can't have spaces without operators in between them, basically. I would get an error, but not only would I get an error, but it would be trying to actually reference some stored value to define the name as, rather than defining it as an exact string coat hook. So when we click on this part, or when we look at it in our reports, we want it to say coat hook, which is why we're naming it this way, right? So this line right here is what I'm defining this coat hook to be, right? This is the material ID number associated with the material that I created previously with the model that has my coat hook. So 2367 is my polished chrome coat hook model. And if you don't know how to find material IDs, I could show you later. You can ask a question in chat. Somebody might be able to just explain it pretty easily. But basically, every single material that you have in the software has an internal ID associated with it, an internal unique ID. And that's what this is. So you might be wondering why I'm not defining the style of each of these attributes, right? Why am I not defining mat ID as an integer? And why am I not defining X as a measurement and Y as a measurement? Honestly, because I'm being a little bit lazy, and because I know that I don't need to for these particular things. Material ID is recognized by Cabinet Vision as a system parameter, and therefore it knows that it's an integer, so it will not change the value if the precision of my software is changed, basically. I don't need to tell Cabinet Vision that the attribute material ID is an integer, because Cabinet Vision already knows that. But it is probably best practice to define it every time anyway, because it gets you into the habit of doing it. So shame on me. But at the end of the day, I know that Cabinet Vision recognizes mat ID. I know that Cabinet Vision recognizes X and Y, and even AY and quantity for the most part. So you don't have to define the style of your attributes every single time. And that's why I have not. So if you want to really, really be best practice, then always define it. Go ahead, and you are an amazing person, and I really appreciate you. I don't have that in me. I try my best, but I don't get it every time. So anyway, so the things I needed to define about this hardware to make it show up and place correctly here are, I don't really need it to have a name, but I like for it to have a name because it helps with my reporting. I need to define the material ID for it. And then I need to link the X and the Y values of this hardware to the parameters that we've created up here. So this is why I find it to be very, very useful to name your parameters something that is very easy for you to understand. Because when we're creating it, it's not so hard to kind of reference the description being produced by whoever wrote it and kind of understand what it is. But down here, when we're actually using it as a value, now I don't have the description right there for me to look at. So it helps for it to be a little more descriptive. But basically, I'm saying I want my hardware's X position to be equal to the value of JDC underscore hook underscore X. I also want the hardware's Y position, or the up down, to be equal to the JDC underscore hook underscore Y parameter. And again, right, here's our X where we've defined it originally at half of the left unfinished end's width. And here's our Y that we've defined at half of our left unfinished end's height. So then our Z value, we don't want to be anything. We just want it to be 0, because we want this piece of hardware that we're adding to rest on the face of the part that we're adding it to, because only when the part touches will the operations that we have associated with the model actually sort of like fire or trigger into that part. So we want to have a Z value of 0 in this particular case, because we're adding the hardware to the left unfinished end. If we were trying to get this hardware added to a cabinet and then manipulate it into position so that it would put its operations on the left unfinished end, this would be different, because at that point we're adding an object to a cabinet which has a different reference point and orientation than the left unfinished end does. So that's a really important thing to kind of remember. When you're adding something to a part, you need to think about the orientation and placement of that part in terms of how what you're adding is going to actually end up existing in your model space. If you think you're adding it to the cabinet, but you're actually adding it to your left unfinished end, you're going to get very unexpected results. All right. So then the AY of 180 really is just going to change the direction of the hardware from its default position. So if we've got this hook going on the face, like the inside face of the left unfinished end, we want our angle to be 180 degrees so that it rotates it around. And then quantity is optional. We don't necessarily have to add the quantity parameter. It's assumed when you're adding something like this that the quantity will be 1. But if this was something that you wanted to be able to control the quantity of, and you wanted to reference a variable of some sort, then you can add it and, you know, set the equation up so that rather than just being 1 here, it references some other variable that we've created. But it's okay. It's not a bad practice to have the quantity showing there. It's just sort of optional in this case. So at this point, let's see what it does. So we've got our left unfinished end. We're going to add a hook. And when we do, as expected, we get some extra attributes that we've defined. We've got the face X position and the face Y position, and they are values that are derived from the size of the left unfinished end. Now, to kind of demonstrate a little bit more that when you create a parameter and you create it by querying for null, the fact that it's really only going to define that value 1 time and then forever on, it doesn't care unless the parameter actually gets deleted. I will show you what happens when I increase the depth of this cabinet. You might think that increasing the depth of the cabinet will make this object sort of move forward or backwards depending on what I do, because we've defined it to have a value of half of the panel's size. Jeremy, what's going on here? Okay. I think this actually might not be functioning as intended, interestingly enough. I am fairly certain these values should not be changing, but I think it's because these are evaluating as equations. Does that sound right to anybody else? Yeah. Yeah. Okay, so I was not expecting that. That's an interesting one for me. I was really expecting it to not move, so that's kind of a neat thing. But if you set it to evaluate right now, I don't think that will continue to happen, but maybe it will. Well, so if you guys have, you know, decided that I don't know what I'm talking about and you'd like to just bail out of here right now, I totally understand. All right. What I can tell you is if we change these values to anything, I mean, even 12.0, and add a 0 to this, now they stay put. So apparently because they are that very, very strict equation referencing variables, until you actually take any control of it, it's going to remain halfway through, which is really cool. I actually did set it to evaluate immediately, Jim. I don't know. So either way, basically, the point is, once you change this, or really once it's created initially, now we have control. That's what I was trying to show here. So now we can move this thing around however we want. And, you know, it's there, right? So if we don't want it and we go false, we still have all of this stuff here, right? And this is kind of what John was asking about, I think, right? How come when we turn something off, the values that appeared, they don't go away? You still see them, even though you don't want the coat hook here anymore. So why are you seeing these values? And that has to do with the fact that we are not ever deleting these values once they've been created. We are not hiding these values by changing their style once they've been created. So basically, we just check to see if these values were null. They were not. They were created, and then we did some things. But later, now it's being intercepted by this exit statement, and all of these values that existed are still here. We're not dimming anything because the dim portion gets like processed every single rebuild, but the values themselves remain. And so there are a couple of different ways that you could do this. If you wanted to just get rid of them when you don't want hooks, like if you just want to delete them, then you would add a couple of things right here where we decide that we want to exit. So let's just say that we made it past our initial check. We wanted to add coat hooks. We got these values in here, but then later our customer changed their mind and they don't want them anymore, right? So the way that you can get rid of those values, or one of the ways at least, is before we exit, after we determine that we no longer want our coat hooks, right? We don't, it's not 1 any longer, it's false now. If you just put a couple of lines that delete the values before you exit, they'll go away. Now, I don't like doing that personally, for the most part. There are some times that I do that. But as you can see, right, when I go to true, we get it. When I go to false, they're gone. This is really good housekeeping to keep these values disappearing. And that I do agree with very much. But what I don't like about this is, what if I've got something placed exactly where I want to, and then, I don't know, my cat steps on my keyboard, or something happens, and it goes away. Crap, I need to get this back. Now it's not where I had it, and I realize that might seem, I don't know, maybe a little bit neurotic for me to feel that way, but when I set a value, I care about it. And if I want it to reset to the default ever, I'm going to actually give myself an ability to reset it. So absolutely. It's basically not necessarily saving them as notes, because to me, that just clutters up my notes now. Because if I don't need this hook, I don't need it, and I don't need any notes about it, so I don't need notes on my reports, so I don't want to clutter my notes up. What I like to do instead is just change the style to a standard attribute. And then because I define my style outside of my null query here, rather than within it, if I decide to turn it back on, when my code passes my exit statement, my style gets switched back to 1. So when I don't want it, my style is 3. When I do, my style is 1. And I'll show you how that works. So now basically what's going to happen is I've got my hook. my cat hits my keyboard or my customer changes their mind or whatever. Okay, no more hook. It's gone. It's wonderful. Then, it was my cat, or the customer changes their mind back again. Now if you... did I not take the delete lines out? I am feeling very strange right now. That should not be working that way. I'm trying to read through this and see where... I think I've got something wrong, because that should be retaining the value. I like that method too, but something is not... They killed style equals 3. Are you kidding me? Oh my gosh, I'm gonna have to fix so many UCSs. Oh, what am I doing? I was literally just talking about this a second ago, being right here. Man. I've been so salty about cabinet vision lately in general, and that does not make me feel any better. I mean, I like it for some reasons, to be honest. I just don't like that it took them so long to make the change, maybe. So this is actually really, really cool. And Jeremy had something set up that now I'm like, this is terrible and awesome. So what I really like about this is you can now link your style's value to your Boolean value. So what that basically means is when your Boolean value is true, your style is 1. And when your Boolean value is 0, your style is 0. Which completely eliminates a lot of code that I have historically had to write to get this to retain values while disappearing. So yeah, that's really cool. Okay. I have a lot of work on my system, so that sucks. But anyway, and I don't, yeah, like, thank you, Jeremy. I don't know if you intentionally saw that and put that in the way you did, or what, but whatever you did made me think about that, and that is really cool. I'll show you in just a sec, Jim, because I'm going to modify this code to be what I just talked about. All right, so hopefully now when I set this to false and then back to true again, we should still retain the values of 12. No, something is still really wrong here. So Jim, this is what I'm trying to talk about, but I'm already... Something still seems... All right, bear with me on this, guys. Changing the style has always worked for me before. I can show you countless situations where I do that. And I'm wondering if just like... Oh, well. There is that. That's what was confusing me there, geez. Are you kidding me, Jim? All right, so all of this. So all of this apparently should just be doing nothing in my version 12 according to that help file. So I'm quite confused. But what I can do is I can show you in my version 12 how this operates real quick, and then we'll get back to the other thing. But basically what I'm doing here is on my my tie racks, on my closet assemblies, if I don't want a tie rack, then I'm setting all of my styles to be 3 so that I don't see them, because I want to retain my values. No, we definitely learned something, but what I'm confused by is why this is working. And it's making it difficult for me to continue kind of talking about what we're doing here, right? All right, so I have a tie rack here, right? And I'm changing it. Okay, now I don't want to see it, but it's still there. Or I don't want to have the tie rack at all, but now I want it back and my value is retained. So this is why I'm kind of a little bit confused right now about what's going on, but I'm gonna look into it, I guess, and I'm going to look into it, and I will let you guys know what I find, because it's definitely strange. So anyhow, that would be the way that I would prefer to do this, would be to retain the value when you toggle it off, but something is definitely misbehaving here, and I'm not really sure what it is, so I apologize, and we'll carry on. So all right, this next sort of iteration, so let me go back, I guess. So at this point, we have established that we can add a coat hook, right? And it goes on the inside of the cabinet, and we can move it around. There's no question. We can move it all over the place. So that's great, but what if we want it on the other side? What if we want to have the hook on the other side of this panel? How do we do that? Or what if we want to have the option to do it on both sides of it? How can we take what we've done already and basically improve? Actually, we'll do that later. This iteration, I'm sorry. So I'm not sure if you guys can hear my cat. Sorry if you do. He's being a little bit annoying. The next iteration, I want to talk about how we can add more than one hook to the panel. So with our first UCS, we had the ability to just add one hook and move it around, right? But a lot of times you're going to want to have the ability to add more than one hook to something, or more than one, whatever it is that you're doing. And this, it's simultaneously pretty complicated, but not, I guess. For me, and I think I've talked about this a little bit before, but it took me a really long time to get my head wrapped around what the while do loop can do, how it does it, and why do I care. But in this particular case, Jeremy had decided to overcome the need to write just multiple iterations of the same code for a limited number of hooks. He decided, instead of writing it that way, to use a while do loop. And so what this basically does is it allows you the ability to add an infinite number of hardware items. You know, if he had not written this with a loop, then he would have basically had to pre-program the number of different hooks that you could ever add, and they'd have to have their own sets of parameters, you know, hook 1, hook 2, hook 3, hook 4, hook 5. And if somebody wanted more than 5 hooks, too bad, you're out of luck, because we only programmed for 5, and if you want 6, you can't. Our code doesn't support it. So using a while do loop, you can basically get past that limitation while also writing way less code, because you only have to write one iteration of it. but it has the flexibility to create as many different hooks or dim as many different objects or whatever as you might like. So, how do we do this? I've gone back to the original for each statement, which, if you don't know about this, again, I think the previous video we talked about it a good bit, but basically this is going to affect left ends, whether they're finished or unfinished or sub ends, right ends as well, of any of those sorts, and then partitions. So this is now available on any of these parts just by changing the for each line. So we've got our few lines of code that are going to create our add hooks, true, false, and then we've got our exit statement, just like before. This is where things get a little bit different though. Rather than just defining an x and y parameter that you can reference, at this point we are now defining a quantity parameter. It's still very, very similar, but rather than being a measurement for x and y, this one's specifically defined as an integer, which is very important during the definition of a non-system parameter. So, right, we don't want to give this UCS to our friend in the UK. I think they use metric. Sorry, I'm really ignorant. To our friends in some place that uses metric because they are smarter than we are. We don't want them to get 25.4 hooks as soon as they bring this UCS into their system because we forgot to define an integer and we left it as a measurement, right? So this is very important when you're defining individual quantities of things to use the integer style definition. Okay, so how do we do a while do, basically? Yeah, metric is so much better. All right, so there's basically a couple of pretty simple, straightforward concepts that are very important with the while do loop that allow you to get your head wrapped around it, and then the rest of the logic is just a puzzle for you to figure out. But in a nutshell, it's a way of counting. It basically says, while this condition exists, do this thing. And it's a little bit different from an if-then, because the while do sort of chunk of code will loop itself infinitely if you never end up resolving to a false statement, right? So like where we're saying if 1 + 1 = 2, then, you know, here's a cookie or something. You don't get infinite cookies while 1 + 1 = 2. It just happens one time and you're given one cookie. But the while do, if you have this basically set, or if you had a while do loop statement that said, you know, while 1 + 1 = 2, give a cookie, like every single time the UCS rebuild, you'd get another cookie because it never ends up resolving to false. You just infinitely over and over and over would continue getting that thing. So we have to introduce a way to, after a certain number of iterations, make that statement become false. In other words, we need to say, while 1 + 1 = 2, give a cookie and change the meaning of 1 to 3. So then the next time the UCS runs, now it's saying if 3 + 3 is equal to 2, then give a cookie, and now it's a false statement, if that makes sense, right? Basically, the loop will happen over and over and over until the condition gets introduced to break it out of that loop. And so we start this by defining a certain value that we're going to change with each iteration. And in this particular case, we've defined it as temp_counter. It's an integer value, and we are defining it basically right now with the colon equals, rather than leaving it to be an equation that's evaluated after the UCS runs. We're saying right now you are equal to 0. So as soon as the UCS gets to this next line, while JDC facehook quantity is greater than temp counter do. So if the temp counter value starts as 0 and you set your hook quantity to 1, now we have a true statement, right? Because now our hook quantity value of 1 is greater than our temp counter value of 0. So now we get to pass through this logic gate. And the very, very, very first thing that I do in this particular case, once we pass this initial logic gate, is I add 1 to my temp counter value. So we're already past this initial gate. So now that this is no longer a true statement, it doesn't matter until the UCS goes and tries to loop again. But basically, we started at 0. We made it through this gate because we want 1 hook and 1 is greater than 0. So now we get to use this neat little operator called plus equals. And I'm going to take just a moment to talk about plus equals. So this is a really, really simple, but I find kind of confusing operator in a way, because it allows some certain things to happen that you cannot do otherwise. And basically what I mean is this kind of adds to a value without overriding it. So if there's some sort of like measurement and you want to take that measurement's value and add a number to it and then assign that to some other like abstract like part or operation, you can use plus equals, and essentially you're not changing the value of the original parameter, you're just adding 1 to it and then reassigning that value to something different. So as your UCSs rebuild over and over and over, you're not actually adding 1 every single time. You're just saying, I want 1 more than whatever the value was before. Now, that's confusing for me to say in this particular case because we are plus equaling 1 to this value that's going to get like evaluated over and over. And so in this particular case, plus equals is actually changing the value. And it's going to like loop over and over and over. And each time this loop passes the logic gate again, the temp counter value is going to increase by just 1. The difference here is that if we were just defining the value over and over and over, it would not take into consideration what value it was before, if that makes any sense. This is literally just a way to add to the value that existed before without removing it and without having to jump through a bunch of hoops, right? If I just tried to say, after this first logic gate was passed, then I'm going to define the temp counter value as 1. Then when the loop repeated itself, it would just keep defining itself as 1. It wouldn't actually be adding 1 for each iteration. Therefore, it wouldn't actually be counting. It would just be defining itself as 1, and it would be a pointless, meaningless exercise, you know? So plus equals allows you to add to previous values without permanently defining the value, if that makes sense. So once we pass this logic gate, we're now changing our temp counter to 1, which is fine. It doesn't do anything. And at this point, we're now going to start defining individual iterations of this loop. So basically right here, we made it past the logic gate. We defined now our temp counter value is going to be 1 because 0 plus 1 is 1. And we are now going to take this value that has immediately changed from 0 to 1, and we're going to start inserting it into these parameter names that we create. So this little section of code here is going to look a lot like the portion of this UCS we were looking at right here. It's very, very, very similar. The only difference is that we are introducing iterations of the while do loop to put numbers behind these values, or really in between hook and underscore y and hook and underscore x. Right, so this is just JDC underscore hook underscore x, but we've got temp counter in between. So, right, that's exactly what the other UCS said. The only difference is that we've got temp counter and curly braces inside of it. So in this particular application, it is very, very important that you are assigning values right now rather than allowing them to be calculated later, calculated after the UCS runs. And basically the reason for that is we need it to be defined as temp counter 1 with temp counter, or as temp counter with temp counter's values on that iteration. And if we waited to evaluate until the end by just having this as an equal sign rather than a colon equal sign, then as we went through each iteration, we wouldn't actually be getting unique attribute names. We wouldn't get JDC hook 1x, JDC hook 2x, JDC hook 3x. We would basically just be getting JDC hook 3, because it's not going to define those values until the very end of the UCS, where we've got our final temp counter number of 3, not getting defined once while it's 1 and once while it's 2 and once while it's 3. And this is, I'm sure you guys are probably seeing, as I try to explain this, why this was a difficult thing for me to kind of understand. It's a simple concept, but I feel like it's kind of complex. So anyway, basically, every time the while do loop iterates, we want to define unique values that can be identified uniquely by associating the loop number with it. And the loop number is temp counter. So on the first pass, we change it to 1, and we define JDC underscore hook 1 underscore x and JDC hook 1 underscore y, because we've only defined that we want one hook. And I will show you how that works here. All right, so we want to add hooks, right? Yes. So we see immediately we've got code hook number 1 here because we only have one hook. So if we add 2 hooks, now the while do loop basically had to process itself twice. On the first time, it kind of like made its way through the loop, and temp counter being 1 assigned itself to the first iteration, and then it was still a true statement when it got to the end of the end while. So it then processed itself again. And on the second time that it went through, it then changed temp counter's value from 1 to 2. So it was then able to, on that iteration, make this next set of attributes, but now it's 1 and 2. And nowhere in the code did I, define this as 1 and 2 or say how many that you could have. I mean, like, look, 12 hooks. And all we had to do was write one simple iteration of the code. Now, you wouldn't want 12 hooks, right? But you could have them. So one of the kind of flaws in doing this the way that this is written, and there is a way to go about undoing this, but I didn't have enough time to work through the logic on it this morning to show you guys. But one of the pitfalls here is basically if you go down, never mind. I think I must have gotten it right. So never mind, forget what I said. No, I'm sorry. I'm totally mistaken. So yeah, as you reduce the number of hooks, you're not getting a reduced number of attributes here because we don't have a loop that goes through and deletes them with another comparison. And there is definitely a way to do that, but again, I just didn't have the time to kind of work through it in such a way that I could explain it to you. So this can get really cluttered and messy, which is why it's really nice if you have the ability to show and hide options. So these could be considered options of your hooks, and maybe you don't want to see this all the time because this is a pretty big, long list of stuff that's taken up all of your real estate over here, right? So how do we do that? Actually, I think the next iteration was, how do we take what we just wrote and do it in such a way that we can actually put hooks on both faces? So it's really simple. You've already done all of the work. You've literally done all of the work already that you need to do. You just need to copy and paste a few things about it. So we already had this attribute in the previous UCS where we were checking for how many we'd like, but rather than saying face quantity, I think I have it just as, oh no, it's still face quantity here. So, right, we just have this one time where we're asking how many hooks we'd like to have on the face. So if you'd like to have the option to have hooks on both faces of the panel, you need to create another ability, another parameter or attribute, if you will, to differentiate between which face you're trying to add or subtract from. So you can simply copy the code and paste it. And then in this particular case, we've taken face and we've replaced it with back. So these are pretty much identical, except everywhere that this top set, these top 5 lines say face, down here they say back. So now we've got, you know, 03 face quantity and 04 back quantity. And the numbering in here is really just to help organize. It's really nothing more than that. It just helps kind of organization, right? So now that we've defined the options for setting our face quantity and our back quantity, which, by the way, by default, we've got the face quantity as 1 and the back quantity as 0. You should set these up the way you think you would want your default to be. Maybe you would want your back quantity typically to be 1 and your face quantity typically to be 0. You should set that how you want. But immediately after we've defined the second set for the back quantity, we just jump right into the same loop. It's the exact same loop. But then we do it a second time. And the only difference between this block of code right here and this block of code right here is everywhere in this set we're referencing face hook quantity, and our AY is 180. Versus down here, we're referencing back hook quantity, and our AY is 0. There is one other difference, and that's the Z. So we've got a Z value of 0 and an AY of 180 for the faces. we have a Z value of the part's thickness and an AY value of 0 for the back hook quantity. So this is part of why I wanted to walk us through these iterations, right? If you try to write all of this at once, you're wasting your time. You are absolutely positively wasting your time. What you should be doing with this is building small chunks of code that you test to see if they work the way you want, and then taking them and treating them as modules and incorporating them into your more complicated set of code. And it is extraordinarily helpful to keep iterations of it the way I have shown here, these different versions, because it helps you kind of see the individual chunks separate from the whole. When you've got a block of, 1,000 lines of code or something ridiculous like that, it can be very overwhelming. Sometimes it helps to just go look at a small section and, reduce the noise of everything else and strengthen the signal of that one part of it so that you can really kind of get your head wrapped around what's going on, and that will help you better understand why your code is failing in your more complex UCS. So write these chunks of code so that they work, and then take them and do things with them. This was so easy to take this from just one face and set it up so that now we can have it on another face too, right? There's one thing about this that I want to talk about, and that is the fact that I'm using temp counter, the same exact the face working plane parameter can definitely be a workaround to the rotation and thickness of the part. Absolutely. Right now, we're not defining a face working plane for it to go on, so it could absolutely. There is no way I'm gonna be able to answer a logic question that Perry can't answer, but I am down to try. What's up, Perry? Yeah, no problem. I'm more than happy to explain it. And we're going really long this stream, and I knew that we would. I don't want to push it too far out, but if I can get through the next little bit, maybe we could come back here and see about introducing the face working plane parameter and taking out the Z and AY values, because technically that would be one less line of code. While Perry is kind of forming the question for us, I want to talk about how this is possible to do this. How it's possible to just reuse temp counter, even though up here we might have changed it. Temp counter started at 0 and it might have ended up at 10. So how can we just reuse it down here after we finished using it for this? That's one of the really cool things about the while do loop. We already used it for what we needed it for. Now we can completely delete it if we want to, or we can reuse it. We don't have to keep track of a bunch of different temp counter parameters or anything like that. We just need to make sure that before we start, we define it right now as the value that we want before we get into the loop. So that's another reason why kind of all of this together done this way, naming your part, hardware, and defining the material ID in this particular thing, and using the while do loop instead of several iterations of if then allows you to just build a block of code one time that is extraordinarily flexible and versatile. I have a lot of accessories that use this exact same format just over and over, and when we get a new accessory, the amount of work I have to do is minimal. I basically just copy the block of code, paste it in there. I do have to do some work with finishes and material IDs and stuff, But generally speaking, it's really, really simple because I've built a strong template to work from. So let's take a look at this in action. We'll do it on this one here. So face quantity starts with 1, back quantity starts with 0. We want to change back quantity to 1. Now we've got 1 on both sides. Okay, so very simply put, we were able to take the code that we had successfully working and copy paste it, make a couple of really small simple changes, and now we've got extra hooks and stuff. One of the things that I do want to talk about also real quick, you'll notice that these are kind of like cascading up and over. This was not the way that Jeremy had set this up, and this might not be the way that you want this set up, but basically what I've done is I have incorporated the counter into the loop. Yes, Perry. Absolutely. It could just make just as much sense to ask how many garment hooks. An answer of 0 would definitely indicate that you don't want any. That would work perfectly fine. And that could be just another way to, you know, reduce the amount of clicks that you're having to deal with and the number of things that you're having to go through. It absolutely could. The only thing, though, would be that you would always, at that point, need to have a visible parameter for the face and the back. So depending on what you value there, you could either always have 2 attributes showing for face quantity and back quantity with a default of 0, or you can have just 1 parameter here and deal with a couple of extra clicks. I actually think it's basically about the same way both ways. So you make a very, very good point. Absolutely. I tend to kind of true false it first before they show up, but there is nothing wrong with what you are talking about, and it would absolutely work just as well. All right, so what about, and I keep kind of defaulting these cabinets because we're just filling these up with parameters, and I'm trying to start us from scratch each time. All right, so this next one is going to be, what if we want to be able to show or hide the options? What if we don't want that stuff showing on our screen all the time? And I was trying to show this to you guys before with a style of 3. I'm really concerned that this is not going to do what I expect. But basically, this is the same set of code, right? There's nothing different from here, kind of down, except we do have this show options thing here. And we've written our attributes for the face and back quantity just a little bit different. I didn't define the style up here. I have instead decided to define the style further down here based on whether or not I've got the coat hook options showing. Right, so if the coat hook options are set to true, then I want my style to be 1. Otherwise, I want my style to be 3. I don't even know what's going to happen since style of 3 apparently is no longer a thing. But then after that, nothing about the code is different. It's just the same set of code that we've been looking at for this while do. It's the same exact set of code down here, okay? So as soon as I add coat hooks, I want to show my options, because as soon as I add coat hooks, I need to do something with it, right? So let's say I've got my hooks here, and whatever. It is what it is, right? So I've got my coat hooks here, and I'm tired of looking at all of this stuff because it's pushing my other attributes down, and I don't like scrolling or whatever. Yeah, what do you know? It worked this time. I don't really know what was going on with that other UCS. I think that maybe having all of these UCSs and everything going on, I might have been something, I don't know. 2022 is all screwed up, but so by doing so, right, I've managed to hide everything but retain the values. So setting the style to 3 for whatever reason in this particular case did work. Our hooks are still here. They obviously are still placed where we wanted them placed, but we're not looking at all of the numbers. And so it does look like you can set your style to 3. Like I said before, I'm definitely going to take a look at whether or not we can just set our style to equal the Boolean value that we're working with. And maybe you just can't, for some reason, reference itself for its style or something. I'm not sure. It would suck if you can't, because it's a really cool thing. But anyway, as you can see here, you can definitely go back and forth between styles based on the value of a variable. So, right? Show options, hide options. It's a really great way when you are getting to a point of having more programming to be able to keep everything nice and tidy. And that's just a matter of changing the styles based on a true or false. All right, so let's just say that you work where I work, and one hook is not even remotely close to enough. You need to be able to offer like 17 different options. Not really that many, but I feel like it's a bit excessive for me. But let's say you want more than one option. How can you go about doing that? At this point, we're starting to get much more complicated, but basically it's still just exactly what we've done, but with several different iterations and a little bit of adjustment to how we write the code. So the first thing that you're going to need to have is a model and a material ID for each and every type of hook that you want to offer, right? If you've got more than one hook, you have to have more than one material ID to reference. So now we're starting to get a little more complicated. We still have our statement here where we're asking if we'd like to add hooks. We still have an exit statement, you know, after that is defined. We've got our show options definition, and we've got our hook face quantity. Here's where we've got something that's a little bit different though. So at this point, I am now creating a list where we can select from a variety of different hooks. So now we've got hooks 3.1 face type, and we're going to offer a belt hook, which is a value of 1, a broom holder with a value of 2, a coat hook with a value of 3, a double hook with a value of 4, and a tie hook with a value of 5. And then after we've kind of created this option for selecting the type of hooks, we're going to define the same exact thing for the back. So we've got our back hook quantity just like before, and we've got our back hook type, which is, again, it's just a copy paste of this entire set of code, but I've replaced face with back. So very easy. And then this is just a further extension of showing hiding options, but now I'm including these additional attributes that I'm creating to help me pick the type that I'd like within this, because now I have additional options that I need to kind of collapse and hide when I don't want to see them. So at this point, we're finally going to start changing our while do loop just a little bit, but not much. All of this is exactly the same as what we've been seeing up until this point. There's nothing different about it. The only part that I have changed is where we define the hardware's material ID. That's it. That's the only thing that's different about this entire thing is these two lists that we've introduced, and then a way to pick the hook from those lists. So if JDC face hook type is equal to 1, we know we want a belt hook. So we're going to name it a belt hook, and we're going to establish the material ID as 2369. And I very much approve of giving yourself a little note over here so that you can see what you're doing, right? So if it's not 1, else, what if it's 2? If it's 2, then it's a broom holder and it gets a different material ID, and I'm letting myself know what this material ID is referencing. If it's not 2, what if it's 3? It's a coat hook, it's this material ID, right? And so on and so forth. So, right, if, then, else, if, then, else, if, then, else. You have to have a matching end if for every if. So once we finally stop doing all of these else's down here, it's just if, and then you can kind of match your if with your end if, your if with your end if, your if with your end if, right? And you know you've successfully correctly closed out all of your if statements. So once you've done this part once for your faces, you can just copy it and come down here to your backside and paste it, and then again just change face to back. That's the only part you have to change. You don't have to change anything about the rest of this because we've built this in such a way that it can sort of function as a template. So now we have the choice of belt hook, broom holder, coat hook, double hook, or tie hook, and the everything else about this is just exactly the same as it was before. So what's that going to look like actually here? I am going to actually bring a new cabinet in because I think I changed the nomenclature of the attributes a fair amount there, their descriptions, and I just want to make this very kind of easy to understand, right? So now, rather than calling it just add hooks or add coat hooks, because I've got all sorts of different options. I've got tie racks, belt racks, broom holders, all this different stuff. Now to me, this is an accessory hook or an accessory or something like that. So now I've changed this to say add accessory hooks, right? When you say true, I should have set this up so the options show right away. So sorry, I just in the iterations didn't do that. But so we set it to true and we see our options. Face quantity is 1, and we've got a belt hook. And sure enough, because we've picked a different material ID than before, we've got a belt hook in here. So if we click our little drop down here, we see we can pick a broom holder. If you select broom holder, because you set your model up and your material ID, now it just changes to a broom holder. And so on and so forth, right? We've got all these different options that we can pick. So as long as you build your model, associate it with a material, and list that material in your list that you're producing here, you could have an infinite number of accessories that are all based on one very, very, very simple set of code. Again, like we have so many options and it required so little. Before the while do loops were really introduced into the software, what we are accomplishing here in 148 lines of code, this would have taken so much more. So the last kind of like iteration of this that I wanted to show, but I didn't, is to introduce, I didn't have enough time to introduce color options, but basically what I was going to do is just add one more selection here. And it would have, instead of being hook type, it would have been JDC back hook color. And then I would have had a list of all of the available finishes for my hardware. And then I would have had basically a little bit more of a complicated sequence of if then queries here. Basically, if it makes it past this logic gate telling me it's a belt hook, then I would have named it belt hook, but then I would have basically said, you know, if JDC face hook color equals 1, then hardware material ID for whatever color 1 is. Else, if JDC face hook color equals 2, then right, the next one, and then the next one, and the next one. And so you can, for each hook type, do iterations to give different finish types for this if you need to associate cost with different products. Another way you can do this is through room finishes if you want, but yeah. So David's got a great point. Set your choice list values to the hardware's IDs. And then probably you wouldn't even need to do these if-thens. You just literally call it out as the ID, and it's, yeah. Very, very, very good point, David. That is a much, much better solution. That would condense this down dramatically from what it is. It would be much, much better, yes. I think it would get a little, I don't know how you could do that with the finish as well, could you? You'd kind of have to pick one or the other, I guess. To kind of categorize it, but I don't know, maybe not. Definitely something for me to think about and look into, because I think that would probably cut back a lot of the work that I've done on a lot of my UCSs. So, all right, this is definitely by far the longest stream we've done. We are at 2 solid hours. I have no issue whatsoever with sticking around for another half hour and talking with you guys about anything. I know that I started slow, and then I kind of really just started rolling through this stuff. So if there's anything about this that's confusing to you guys, or that you'd like to know more about, ask away. Yeah, you're right, Jeremy. You could literally have the entire thing just one really long list. And you could group them together. It would be like all the belts: belt chrome, belt nickel, belt gold, belt slate, belt black, and then you kind of categorize them. Yeah, same thing, David. Basically, you could, I was thinking about doing the other way, but you would pick one thing that filters the list to those. It could definitely be reduced from what I've got. And that's a really good actually, that's a really, really good example of how if you can manage to, it's really hard for me to try to even express what I'm thinking right now, but basically, a lot of times I find when I finished writing something, I look at it and I wonder what the heck I was thinking and why did I do it that way? Because I have just done like over and over and over these calculations further down in my UCS when I could have just done them one time up at the top right away, and then carried those calculations with a variable. Basically, I guess the best way I can try to describe what I'm talking about is try to get work done in your UCS as early as you can so that you can lean on it later in your UCS. Write equations and store the values and reference just a value instead of a long equation if you need to over and over, and just try to get the work done a little bit earlier in your UCS, and it will make reading the later stuff in your UCS easier. Okay, so gem. So the whole idea here was that if you wanted to set something up so that when you toggle options, like show options true or show options false, right? That's a Boolean statement that would be 1 or 0. So if I want a set of attributes, I'm going to see if I can just write something completely separate from all of this to kind of demonstrate, because I still feel like I was running into something strange. Let's see. Oh, darn it. I missed this one. All right, so let me see here. So let's say that I don't want to see anything if zparm1 is false. Right? Delicious. If zparm1 is false, I don't want to see any of these other attributes. So what I think we might be able to do is we should be able to say that I want the style of each of these to be equal to the value of zparm1. So when zparm1 is false, ideally, we don't see any of them, right? And all I had to do was say that I want for the style to be equal to this true-false statement. So when it's false, the style is 0, therefore it's a standard parameter, therefore it does not show. When I set it to true, now I see all my Parmesan cheese wedges, because they're literally having their style reference the value of my show options parameter. And it completely takes away the need to have any stupid, if this equals that, then set my style to this, otherwise set my style to that. All I have to do is just define my style to match the value of my Boolean show options statement. Yeah, this is insane. This is such a cool, like, code simplifying thing. I'm so thrilled that you guys pointed out that style equals 3 died. I didn't even know it. And, like, this is kind of nerding out a little bit. This is really exciting. I'm really... I feel like somebody did something really cool here, right? Because before I would have had to have basically said, if z parm 1 equals 1, then right? So it literally cut the code in half, more than, because this would have been how I would have had to have done this before. Same exact results, but twice as much code. So that's a really, really cool feature that's gonna probably, I think it's gonna simplify a lot of what I write. So it's really neat. I'm pretty stoked about it. So thank you guys all. And Jeremy, thank you. Not only thank you for giving us this sort of foundation to build from. I know that it looks a fair bit different from what you gave me, but I hope it feels like really, really similar. This is absolutely just based on what you gave me. Thank you very much. I think it worked out really well. It was a really great example, and I hope that this was a not too complicated, decent introduction for those of you who are a little bit less familiar with writing user-created standards. And I really hope that the way we kind of started small and worked our way up will give you a little more confidence in what you're doing. I think it's I just think it's really important to start small and just take really small bite-sized chunks out of this thing, right? This could have started as somebody saying, hey, Brandon, I need you to give us options for every single accessory that exists in the tag catalog. And that is a very, very daunting, overwhelming task for me to hear. But if I take that information and I really break my task down and say, okay, how can I actually do this in such a way that I can leverage this? Do I need to write 30 different UCSs? Or do I need to write one UCS that I can kind of like copy and paste and make, little modifications to, so that 90% of the work is done with 10% of my time. And yeah, so a couple of weeks from now, we are going to be, I think we're scheduled right now for March the 23rd. Let me check my calendar here. March the 25th. So on March the 25th, you guys are going to get to, if you want, stop listening to me finally, and David has agreed to hop on stream with us, and he's gonna walk us through honestly a fairly complex system that he's using to set some doors up for various different, basically, I'm gonna do a terrible job of explaining it, but it's a set of UCSs and settings and methods that you can use to produce 5-piece doors and machine them and basically get them from raw material to finished product, all with Cabinet Vision. And it's I'm pretty excited about it. I'm pretty excited to see what he's going to show us. And thank you, Jeremy, very much. Thanks for coming by, and you have yourself a good afternoon. So we'll definitely be doing that on the 25th. Please mark your calendars and show up. I think we're going to do it at the same time in the morning, unless anybody, we've got a couple of weeks to basically plan and see what works best for people. I try to pick 10 a.m. PST on Fridays because that's late enough in the workday that anybody wanting to watch has probably taken care of their morning things and can maybe, put their regular responsibilities on hold. But on a Saturday, that's like 1 in the afternoon. So that might not be great for everybody. So we'll talk about when we're going to stream on Saturday, but definitely Saturday the 25th. And yeah, just stay tuned on the forums. We'll be talking more about what we've got going on. And I think actually one more thing. I think the Friday before that, so that would be, yeah, Friday the 24th. So I think I'll be doing back-to-back streams. I'm going to have somebody from the Cabinet Vision forums on, and we're going to interview. We're going to talk about their shop and some of the things that they've got going on and the ways that they like to use the software, and just get a little bit of a different perspective than what you guys have been getting from me. So yeah, I think that this is going to actually develop and continue to be something that we do pretty consistently, and I'm actually really excited to try to get some of you guys on here talking about the way you use the software. It's really cool to see it in a little snapshot of the things you post on the forums, but it'll be totally different to get you to operate the software for us and just talk about it. So thank you guys all for showing up and contributing. Once again, I learned something really cool on the stream, and I hope that you guys did as well. And I will look forward to seeing you guys all next time. Take care.